what really happened was behind the scenes, the website failed. So at the cost of downtime, downtime is more expensive than most people realize. So according to around $5,600 for every minute the systems are unavailable. That is every single minute they $100. So now imagine large companies like Amazon, Facebook, and others. For, for Amazon, um, even $8, I'm sure everyone knows this. In 2021, Facebook, Instagram, um, Facebook invalid for several hours due to a configuration issue. I'm sure we heard of this news that time. Um, so millions of users were affected. Business were very big. But the impact isn't only financial. It's when services when services go down, people lose trust and the business for another one. So the business also loses its productivity. And sometimes even the company loses the users permanently. They won't come back again. So it's really take. Before we talk about failure, what to go right every time you open an app or visit a website. It feels instantly because you click and it open, but you don't know what is happening behind the scene. Several systems are communicating with each other. First, your device you open, you tap an app, your device sends a request across the internet. The next name into an IP address. That is the work of the DNS server. So that is similar to how a phone book connects with the phone number. Those two networks until it reaches the company server. Then we have the load balancer. It's the load balancer decides which server. Then when it comes to the server may also communicate with a database to retrieve your account information or data. So finally, we have the response. The application opens on your phone, and everything happens very fast. But the important thing to understand in this is that every step, the first one to the last one, every process in this is a possible failure point. It can fail at any time. It can fail at it can fail at number 3, 4. Any one of the component fails. Users may experience slow, even error. So this the so number one is the most common one, which is the human error. An engineer may or deploy a faulty code, then a configuration may be changed incorrectly. Then that is and another. So even experienced teams and big engineers they all make mistake, especially high pressure situations where fail. Servers are still physical machine, so hard drives fail, power supplies stop working. Even network equipment can break when is cyber attacks, especially DDoS attack. I'm sure most of us are familiar with this attack. So this is when attackers flood the system with a massive until the server become overloaded and unable to respond or even slow to. So the fourth one is without working on properly. Users might not even be able to locate the website they're trying to go to. And finally, we have this cascading failures, multiple other problems across interconnected systems. So eventually causing much larger just a small issue can affect the whole entire platform. So reactively mistakes. So let's look at this story. In 2017, Amazon AWS experienced a major outage about than intended while troubleshooting an issue. Okay, that single mistake affected a large portion of the internet. That day, most of us a large portion of the internet for several hours. So many websites, popular websites, we know they were all down. So in 2019, Cloudflare released a software update containing a so Cloudflare handles amounts of traffic globally, so the issue caused widespread disruption across many services. We also do have the this story 2021 phenomenon outages in the most recent years. So a network configuration changed on each other. So even engineers struggle to access the physical, the internal tools needed to fix the problem. Because even those, so they couldn't even log in to fix the issue. So the Facebook remains offline for hours. So, so these are the why even the best engineers in the world make mistakes. So we have prevention strategies running 24/7 behind the scene. Um, so how do companies reduce the risk of is redundancy. Critical systems always have backup. That is why backup is very important. So instead of relying on one server, database, and even multiple network connections. So if one component fails, another one immediately takes over. So everything doesn't for one is load balancing. So traffic is distributed across many servers. So no single machine becomes uh, overwhelmed auto scale. So when traffic spikes, new servers spin up within seconds to handle health checks, which is the health monitoring, is also very important. Automated systems, they continuously check whether the servers are healthy. And traffic can immediately be redirected from away from the system. And finally, we have the staged deployments, which is drone software updates. So instead of revealing the new code to everyone at once, companies review it review it when they say when they're testing the websites or a new tool, something like that. So if something goes wrong, the update can quickly be rolled back our platform or website. So we have how engineers detect and respond to incidents. So number one, we have the monitoring and infrastructure are being monitored constantly. So teams they track the CPU usage, uh, memory usage. So they monitor everything. If abnormal activity is being detected, alerts are immediately sent on call rotations. So if anything are down, alerts are immediately sent to the engineers who are in charge of the so we have the run books. So we have the run books predicting step by step guide so engineers don't think first. So we also have the post teams. So the culture the goal is not to blame individuals. Instead, teams analyze what happened in our incident investigation. So the culture of learning and continuous improvement is the, the part of modern engineering profession. What 5 nines really means. So 99% of uptime sounds very good or impressive until it's of downtime every day. Then we have the 99.9%, that is 8.7 hours. The 99.99, which is the enterprise standard, is about 52 minutes. The 99.999, which is the 5 nines we are talking about, is only 5 minutes of downtime per day. Traffic, this is what they are trying to maintain. So achieving this level of reliability is very different. Um, Advanced infrastructure, even highly skilled engineers. So that is why we have reliability engineers. Behind every outage is an engineer having a bad day. So for the person that that makes the system failed. So but now it has shifted. We run engineering teams is to ask a different question, which is not who is in charge of this, who made this. So the right question is now is to cause this most damage. So we fix the problem, not finding the person that caused the problem. So That is why DevOps exists. But yet the teams build software and those who run it barely talk. So DevOps broke that down. One team shared responsibility and shared ownership on call. Someone right now, engineer is being woken up by at 3 a.m. and alert. That is the new demanding part. So key takeaways. So first, modern application depend on many interconnected system working together constantly, unavoidable. So no system is perfect. Third, we have the reliability is that achieved through redundancy monitoring. So we have the fourth one. Many outages are caused by small issues that go into large failures. And this online is not only a technical challenge; it is also a people and process challenge. Any questions?
All right, thank you so much, Austin. Because of our time, we might not be able to take question. Some of us have to drop off to join our stand up now.
All
Thank you
right.
once again. Thank you everyone for joining. Do have a wonderful day. Bye.